right, number 19, it says find the value of x, round to the nearest degree. We have an angle and we have two sides. We're going to use one of our trig functions, which is we have an adjacent side and we have the hypotenuse, and cosine uses adjacent over hypotenuse. Cosine of x degrees equals 7/17. When you find x, you want to get x by itself, you're going to take cosine over to the right side of the equation, and when you do that, you actually do the inverse cosine. That would be the opposite operation of that. And I take the inverse cosine of 7/17, which gives me x equals 66 degrees. Number 20 says draw the image of the figure after you rotate the figure 90 degrees about the point 33 and then rotate it 180 degrees about 0, 0. So we're going to do the first thing, which is to rotate it about 90 degrees about point 33. Point 33 is right here. And so we're going to take this whole line and rotate it about that point. But you start by just rotating the other end of the segment, and then you could just connect the dots. So I want to go 90 degrees. You can measure off 90 degrees, but you're just wanting to form a right angle, so it should look about like that. It should be a right angle. And then if I rotate that point about it, I want to be the same distance from 3, 3. So this is 1 diagonal, 2, 3 diagonals away, so I want to do the same thing here and go 1, 2, and then 3. So we should have a point right here. And so when I rotate that 90, that would be my segment. Now I'm going to take my new line right here, and I'm going to rotate that one 180 degrees about point 0, 0, which is the origin. So I'm going to rotate about this point. First I'm going to call this A, and I'm going to call this point B. I'm going to rotate A 180 degrees. Draw a straight line right through the origin and point A, and it is 3 diagonal units from the center. So I'm going to go 3 diagonal units from the center here, 1, 2, and 3. So I'm going to have a point here. This is A prime. And I'm going to do the same thing with B and draw a line from B all the way through the origin. It should be right along the y-axis, and it is 6 units from the origin. B is, so B prime is going to be 6 units from the origin as well, which is approximately here. And I'm going to draw that segment. So your final segment should be here, which would be A prime, B prime. All right, so for number 21, it says in the figure the horizontal lines are all parallel. So AB is parallel to BC, or AB is equal to BC, and BC is equal to CD. So once we know that one line, transversal, is broken up into congruent parts, then we know any other transversal that goes through the parallel lines is also broken up into equal parts, which means that these guys are equal and these guys are equal. It does say that we want to find KL and FG. So KL would be the same as LM because they're congruent. So the measure of KL would be 8.8. And then it says FG, this is just labeled wrong. There should be an F here. Since EF is 4.1, then FG is also 4.1. Okay, for number 22, it says you're planning to use ceramic tile design in your new bathroom. The tiles are blue and white equilateral triangles. That's kind of important there. You decide to arrange the tiles in a hexagon. If the sides of each tile measures 4 centimeters, what will be the exact area of each hexagonal shape? Equilateral triangles have all sides are congruent. So if I look at just one of the triangles, I know that they are all 4, 4, and 4 around one of those triangles. And so we're going to use that to help us find the area of the entire hexagon. We just want to use one triangle at a time. So I'm going to make a larger triangle down here. We'll say this is an equilateral triangle that measures 4, 4, and 4. And I have a formula for the area of a polygon. The area of a polygon is 1/2 the apothem times the perimeter. The apothem is if I take one of those triangles of my polygon and draw in its height, that's the apothem. So in order to do this, I need the apothem and I also need the perimeter of the whole hexagon. The apothem, I'm going to use a little trig for that. It is perpendicular to the base of that triangle, and because of that, it's also going to be congruent, or going to make two congruent parts. So instead of having 4 for the whole base, if I just focus on this right triangle, which is what I'm going to do, I should realize that it has a base of 2, just the right triangle. And then I need to find the central angle. This is a central angle. All the central angles of a hexagon are 360 degrees, so I'm going to take 360. A hexagon has 6 sides, so 360 divided by 6 is 60 degrees. All of the central angles are 60 degrees. Which, if I look at just half of that triangle, I am going to take half of that central angle, so this measure is 30 degrees. Just focusing on the right triangle for a minute, that's going to help me find the apothem, and I'm going to use my 30-degree angle and a little bit of trig. I can either use the hypotenuse or I can use the 2, which is the base. I'm going to use the hypotenuse, so I have an adjacent side and the hypotenuse. I'm going to use the cosine of 30 degrees is equal to the adjacent side, which is A, that's our apothem, over the hypotenuse, which is 4. And then to solve for A, I'm going to multiply both sides by 4. That's going to give me 4 times the cosine of 30. And A then is approximately 3.46. So now I have A. The perimeter, let me use the top here. A is 3.46. The perimeter, we know that one side of the hexagon is 4 centimeters and we have 6 sides, so the total perimeter would be 24 centimeters. Once we have the apothem and the perimeter, we're ready to put it into our formula. The area is 1/2 the apothem, which is 3.46, times 24, which is the perimeter, and so the area is going to equal 41.52 centimeters squared. For number 23, the surface area of two similar solids are 400 yards squared and 1,084 yards squared. The volume of the larger solid is 1,756 yards cubed. What's the volume of the smaller solid? That's what we want to know. volume of the smaller solid. What we know about similar figures is that the area, the surface area, can be represented as side squared over side squared, and volume can be represented over side cubed over side cubed. So I'm going to first take my area, and I know that that's equal to a squared over b squared, which I have 400 over 1084. And this is going to represent the ratio. I'm going to take the square root of both of these, which is going to give me the square root of 400, which is 20, and the square root of b squared, which is 1084. B will be approximately 32.92. And then I know if I square those, or if I take those and I cube them, that's equal to the ratio of the volumes of the figure. We don't know the smaller one, so I'm going to put an X there, but we do know the larger one is 1756. So I'm going to put that there, and I'm going to work this proportion. Do a little cross multiplying. I have 32.92 cubed times x is equal to 20 cubed times 1756. Then if I divide by that 32.92 cubed, that'll give me x, which would be the volume of my smaller figure. And that answer is 393.8 centimeters cubed. Number 24 tells me that CD is 44. We know that OM is 18. Let's see, 18. We need to know that ON is 16. We also know that CD is perpendicular to OM, so that forms a right angle. We know that ON is perpendicular to EF, so that forms a right angle. And we want to find, first part says A, find the radius. It doesn't say express in radical form, but I'll also take decimal approximation. If CD is 44 and we have OM that's perpendicular, it's also bisecting. So we know that these two are congruent, so MD and CM would be 22, half of 44. The radius is the distance of from the center to any point, so I'm going to connect any point on the circle. I'm going to make a segment OD, and that's going to represent my radius, and I'm going to do Pythagorean theorem to find the radius. So this is for part A. I know that I have two legs, 18 squared plus 22 squared is going to equal r squared. And when I solve for r, I find that r is equal to 28.4. So that's part A. And I can fill that in here. And then I want to know about how long FN is and how long EF is. So FN, I'm going to use the fact that